Hello class, this is Mr. Beltran. Our objective for today in math class is understanding the rate of change in a graph. Our agenda, as we have in class, is to do like do now, notes, then there are notes, to do a practice question together, and then self-check on your self-check. Those are your assignments on Study Island. I understand that I'm on top of all the questions you have on Study Island. There's a few of them at a time until we get to your questions that you have on Study Island, but you should still work on them. Okay, over here we have our table of contents where you get there for your notes, a rate of change in a graph. This right here is our practice question. Over here we're going to move on to our do now. The do now is what we're going to do first. We have number 1, 12 inches to 1 foot is equivalent to 48 inches. And how many feet? Over here, 30 minutes is equivalent to half an hour. How many minutes are equivalent to 3 hours? Over here we have our question number 3, goes along with our graph. What are the intervals for the y-axis going by r? How many units are between each tick mark? Here we have question number 4. What are the intervals for the x-axis going by, or how many units are between each tick mark? And when we look at our graph, we need to pay close attention to how it's labeled. Over here we have our tax. Again, this is in dollars. But however, when our tax, we look at our intervals, it says it's in tens. Over here, our price in dollars, but our intervals are in thousands. So right here, between 0 and 1, is actually 10 to 10. From 1 to 2, that's another 10. From 2 to 3, that's another 10. It's going by tens. Over here, we're going by thousands. So right here, 0 to 2, that's 2,000. From 2 to 4, it's 4,000. From 4 to 6, that's 6,000. So we need to make sure we pay close attention to our intervals and what it says in the labels. So what are intervals for the x-axis going by, or how many units are between each tick mark? So I'm going to give you some time to work on this. At this time, you can press your space bar, and once you press your space bar, it's going to pause this video. As the video is paused, you're going to work on these questions. At this time, you're pausing the video. After you're done pausing it, I'm going to go ahead and press and show you our answers that we get for these questions, and see if you came up with the same answer. Over here, for number 1, you want to know how many feet are in 48 inches? It's right here. It's going to be 4 feet. You want to know how many minutes are in 3 hours? So right here, we're going to have 180 minutes. So we're going down to question number 3. What are the intervals for the y-axis going by, or how many units are between each tick mark? Well, we're looking at the y-axis. We're looking at our vertical lines. It's going by 10. So when we see this written, we're going to write in a question. There are 10 units between each tick mark. Between each tick mark. Or the intervals are going by tens. Over here we got question number 4. What are the intervals for the x-axis going by, or how many units are between each tick mark? In our case, there are 2,000 units between each tick mark. There are, we're doing this in a complete sentence. There are 2,000 units between each tick mark. Each tick mark. Okay, well, question number 1 and 2. If you got this, awesome. You go ahead and prepare to take your notes. Remember our notes for our table of contents. You're going to have the date, table of contents on our page, rate of change, and a graph. These are not the notes. This is not the note. This is the practice question. I want to have up here the notes that go along with rate of change. If you have this already, you can fast forward this. I'm going to explain how we get 4 feet and how we get 180 minutes. Those are for the students that don't understand why this would be 4 feet and don't understand why this would be 180 minutes. Okay, question number 1. We have 12 inches to 1 foot equals 48 inches to how many feet? When we do this, we have to remember that our labels are the same, going horizontally. When we do this, we can do cross product. We do cross product. We multiply 12 times our unknown equals 48 times 1. 12 times our unknown equals 48 times 1. 48 times 1 is 48. 12 times our unknown. Right here, it's telling us that we have to multiply something that will give us a 12. When we do that, that's multiplication. We're going to do the inverse of multiplication, which is division. So we're going to divide by 12. What we do to one side, we're going to do to the other side. When we do 48 divided by 12, we get our unknown to equal 4. Because 12 times 4 gives us 48. 48 divided by 12 gives us 4. We have our 4 feet to question number 1. Now we're going to question number 2. We're going to erase this and put question number 2 up here. Then you could have paused that to get the understanding of question number 1. We're going to question number 2. How do we get 180 minutes? We have 30 minutes equals half an hour. 0.5, same as half an hour. We want to know how many minutes are in 3 hours. We notice that our labels are the same going vertically. We have minutes, minutes, hours, and hours. So now we can also do our cross product. We have 30 times 3. 30 times 3 equals 0.5 times our unknown. We do 30 times 3. That's going to give us 90. Equals 0.5 or half times what we don't know. Then we're going to do the inverse. It's telling us to multiply. We're going to divide. We're going to divide by 0.5. We do to one side. We're going to do to the other side. So now we have how many times can 0.5 go into 90? 90 divided by 0.5. So we have 0.5, 90. Now you remember, we have that decimal point right there. We have to move that over. When we do that to this number, we're going to have to do it to our number within our division box. So we have 5 goes into 900. How many times? 5 goes into 9. 1 time. 9 minus 5 is 4. We bring down that 0. 5 goes into 40. How many times? It goes in there 8 times. 8 times 5 is 40. Then we subtract that. We bring down that final 0. 5 goes into 0. 0 times 5 is 0. 0 minus 0 is 0. So we're done. We get 180. 180 minutes. That's using cross product. There's other ways you can do this also. If you understand that 30 minutes are in half an hour, we have 60 minutes equal 1 hour. If 60 minutes equals 1 hour, how many minutes would be 3 hours? Well, 60 times 3, that gives us 180 minutes. Again, class, as I said before, doesn't matter how you decide to do it, as long as we're doing it and we're getting the correct answer. You could use either method. We can use a table, you can use cross product, make sure that we have our labels in the correct situation there. Okay, class, that was the do now. Now what we're doing is, those are the answers for our do now. We're moving on and we're gonna do notes. So go ahead and take out your notes, booklets, and that's what's gonna be up here next. So right here we have our note page. I want to erase what's on there. Hopefully if you still need that, that's up there. But you can always pause the video whenever you need to pause it. You can fast forward, you can rewind it, whatever is necessary. So understanding rate of change. We have to remember, to put a star there, that the rock is the cop. Yes, the rock is the cop. And we all love the rock. So the rock right here is the cop. What does that mean by rock in this case? The rate of change. The rate of change is the constant of proportionality. And if you can't see what's on the bottom, don't worry, we're going to bring it up. How is this described? How is the rock or the cop described? It is described as the ratio of one quantity to another quantity. Well, we have this example. George, he's gonna babysit for his neighbor. He puts this data in a graph. So we have this graph down here of the data in which George is gonna be being paid for watching the children next door, watching his neighbor's children, because he enjoys watching children. As I told you before, class, if you end up finding a job you enjoy doing, it doesn't seem like a job anymore. It doesn't seem like work. That's what we're doing here. And anytime you did not get what's there, you can pause it. So we have our graph here, the amount he's gonna earn. We notice that the increments, as it says, we're looking at our y-axis, we're looking at our x-axis. On our x-axis, we have our hours. On our y-axis, we have the amount that's earned. We're looking at where these points are at, along our graph. We're getting this down in our notes as we're discussing this. As we look at the graph, we will notice different things. As each hour goes by, he earns more money, which makes sense. The longer you're there, you're gonna earn more money. The line is going upward, towards the right. As like when we're reading a book, read a book towards the right. So he's going towards the right and he's going up. Since the hours are getting longer, the amount he earns gets higher. Yes, right there it says she, but I need to change that to he. The amount he earns gets higher. It appears that for every 2 hours worked, he earns $15. Let me go ahead and fix that real quick. And that's why we use pencil, class. I know some of you are at home using that pen, but it's always good to use a pencil. See, we can just do this easily, and we change this to he, and change this to he. Those are the things that we notice. He appears that for every 2 hours worked, he earns $15. That is a rate of change. Is that the unit rate? We're going to talk about that later, but that is part, sometimes the unit rate is the rate of change. So the rate of change can be the unit rate. But is it the unit rate? No, it's a rate of change. So for every 2 hours, he gets $15. That's what we're looking at in our graph here. 2 hours worked, $15. 4 hours worked, $30. 6 hours worked, $45. And more than likely, he's not gonna work longer than 6 hours. But in case he does, he works for 8 hours, he's gonna get paid $60. So that's our first graph. Now we need to understand this, and this is our rate of change. It appears that for every 2 hours worked, he earns $15. Well, if one person is earning money, not everyone's going to be earning money, because the neighbor has to pay George. Since the neighbor is paying George, George is earning money, but the neighbor is losing money. So we go ahead and we go to the next page. Yes, your notes are going to continue a little. It says understand the rate of change in the graph, because your graph is not always going to be going upward. In this example, the neighbor has to pay George for babysitting. The neighbor has $45, and wants to know how much would have left after a certain amount of time goes by. So at this time, he starts at $45. He's beginning at $45. And as each hour goes by, he's losing money. He's not gaining money because he has to pay for the babysitter. So he's noticed that this line is a decreasing line. It's decreasing. As we look at the graph, there's some things that we're going to notice, like we talked about, or like I just mentioned, that it's decreasing, it's going downward. Like we're reading a book towards the right. And as we read it towards the right, we notice that this is going downward as it's going towards the right. You want to know how far is it going towards the right? And there's different ways you can say this, yes. That is also the rate of change. As we look, we notice each hour goes by, the neighbor loses money. The line is going downward towards the right. As the hours are going by, amount the neighbor has been subtracted. It appears that for every 2 hours that goes by, the neighbor loses $15. So in this case, instead of having a positive rate of change, this is going to have a negative rate of change. This is decreasing, negative rate of change. The graph that we had before, that is a positive rate of change. This is negative rate of change. We see this as as it is decreasing. It appears that for every 2 hours that goes by, the neighbor loses $15. Those are our notes. Over here, we have our practice question. So if you didn't get all the notes, or if there's a time to pause, we're moving on. Rate of change in a graph, our practice question. Sherry is a realtor. She made the graph below to show the amount of taxes paid on the house she has sold. So we have our taxes and thousands of dollars. Over here is the appraised value for those homes. The value of the homes after they've been appraised. And hundreds of thousands of dollars. Of course, when a house is appraised, it's not going to only be appraised for $1. And sometimes when you write all those numbers in, it can get confusing. So right here, instead of just being 1, it's going to be $100,000. Right here, instead of 2, it's going to be $200,000. Over here, we have taxes on our y-axis. Instead of taxes, 1. Can you go ahead and press pause when we get that? We're going to do this video